Good afternoon, everyone. Today we have another workshop, pump introduction, held by Aitam Bakur, a very well known and experienced wash expert, wash coordinator of ACO, NGO in Syria and Turkey. We thank him a lot for this presentation. And this is the first one of a series of presentation about pumping and pumping system and water supply system. At this point, I give the word to Haitam.
السلام عليكم الله يعطيكم العافية.
Many thanks for you. Today we are going to speak in the first session about the bomb. This is Haitham Al-Bakour, Mechanical Engineering, 2020 graduated, 2002 graduated, and I work as wash coordinator with ACU. We are going to start about fundamentals of bomb science, categorizations, and else. These are used more than 95%. It has horizontal and vertical kind of bombs and different kind of bombs. At first, what is the purpose from using the bomb? We are using the bombs to move the water from a low level to a tank in higher level. So from low pressure area to higher pressure area. For example, we are pumping the water from tank A within a population of low pressure area to another tank B to serve the population there. The other example that we are pumping the water from a well into a ground level tank to serve the population through using pump 1. As pump 1 is transferring the water to the first tank, while the pump 2 is going to transfer the water from below the building to the building. So the pump usage is to transfer the water from a low pressure area to a higher pressure area. As we can see in this chart, it is transferring water from lower tank to the other tank in the upper right corner. We are going to talk about the parts of the bomb. We are going to talk about this pump. It is containing the inlet where the water is going in, then the impeller, and this impeller is raising the water to the outlet, and there where the water is transferred and being pumped to. Then the casing, and it's in red, as you can see. 4, it is the bearing, and it is responsible about the shaft to be in a stabilized position. The other part is the shaft of the bomb, and it is the part transferring the power from the engine, either it's electrical diesel engine, to the impeller to move the power and make it movement rotation, and the shaft seal, which is protecting the water within the pump and preventing it from being leaking to the bearing and the shaft, sorry. As the water there in this section is guarded and preventing it from leaking. We can see in this chart this section of the bomb. As we can see, it is the entrance. The water is going to the impeller, and the impeller pushing the water upward to the outlet. And the shaft here is moving the movement to the impeller. We can see here an example about it. It is a movement example, a very good one, from the inlet to the impeller and then to the outlet. pumping the water to the upward outlet. The water are entering here from the inlet and move to the entrance of the impeller, which we call the eye of the impeller. And in this chart, it is going to be from down below, and then the water is going between the impeller, and it is going to be in the surrounding, gathered, and then it's going out through the outlet of the bomb. This is another chart with more details and more naming of the parts to have more details about every part of this bomb. We are going to about the classifications of centrifugal bombs. We are going to speak in concise, in short, not in detail, as many classifications are based on the reference and the company it's categorizing this. And we are going to talk about centrifugal pumps used in everyday life routine. One of the classifications for the pumps, it is about the shaft position. If it is horizontal, it would call horizontal pump. While the shaft is on a vertical position, it would be a vertical pump. And when it is within and where there is one impeller in the bomb, it would be called single stage. So the bomb on the right would be called vertical single stage, while the one on the left, it is horizontal single stage. We can see here two other kinds of bombs. The one on the right, it is a horizontal bomb, and it is multi-stage bomb. When we have more than one impeller, we have multi-stage pump. On the left, we can see a vertical multi-stage inline pump. There is another categorization for the pump. It is based on the end suction pump and how the water is going to exit the pump. So we have the first categorization as end suction pump. So it is going into the pump and going vertically on the line of the pump. While the other kind is the direct pump, which is inline pump. So the water is going on vertical way and going through the same way. And we can see different designs of the inline pump and the end section pump. And there is another categorization for the pump where the motor, the engine is separated from the pump, and there is something attaching them, connecting them together. So it's a long couple, but where it is directly connected with the engine, we call it closed couple. We can see here in this chart the many classifications based on one style of companies, which is covering a very big part of the bombs, but we can't talk about all classification of the bombs as we have many different kinds of those, either vertical or horizontal, single stage or multi-stages.
وهناك تصنيف آخر للمضخات.
And there is another categorization for the bombs
حيث يوجد
based on the impeller shape or style. So we have the impeller where this shape is like we have the entrance of the water from one side So it is a single suction impeller. So we call it single suction impeller. While in some impellers where it is the water is coming from two sides, we call them double suction impeller. And the difference here based on the design of the format of it. We are going to speak about the one side suction impeller where the water is coming from one side and going from the surrounding. And this is the shape of the bomb. While the second shape, which is a double suction, so the water is going from two sides from the impeller and going out from the surrounding, and it needs a special design for the bomb and its body. We can see here in this picture, we can see here it is in the upper part where the connection here and the shaft beds are putting in different places. It is going to be on the sides of the impeller. And there are some other categorizations for the bomb. We have submersible bomb, completely submersible bomb, where the engine, the motor is going to be inside the water completely, and those have been used in the wells mostly. And the other kind, which is immersible bomb, immersible, not submersible, and those are vertical kind of bombs. And the motor or the engine is outside of the water, just like immersible bombs. We call them immersible bombs. What are the advantages of centrifugal bombs? The bomb has a relatively simple shape. As we witnessed, as we saw, it has a very simple shape, very easy to be installed. It has low cost in comparison to other kind of bombs. Thirdly, it is really, its reliability is high, minor faults, and doesn't require much maintenance. If you chose your bomb appropriately with high standards, it can work even for 30 years or more in continuous situation with some minor maintenance. Fifth, it is multiple possibilities and uses, as we can use it for drinking water and for sewage water, for chemicals, even for hot water. In addition to that, you can use it with different kind of usages as for the power and for the flow. We are going to provide you with some details later on. As we have already told you, for the centrifugal bomb, it is more than 60% use of the bombs. We have different kinds of bombs to be used here. There are different kinds of bombs, but it has very high cost. We are going to speak under the second topic about the bomb power equation. How we can have those equations, how we calculate and come to those equations. Firstly, we are going to speak about the electrical, the sequence of power transmission of electrical bombs. We have electrical engines transferring the power to the bomb. We have P1 electrical power through the electrical wires to the motor, to the engine, and then we have mechanical power, P2 on the shaft of the engine, and this mechanical power would be transmitted or transferred directly to the pump. Within the pump, it's going to be pH, hydraulic power. The power is going in through the wiring, then it's going to be as mechanical power on the shaft of the engine as one mass, and then it's going to be out as hydraulic power. The first shape is going to be the pressure shape. The other form is going to be the flow, which is related to the amount of water we are pumping. And we can see that we have waters with specific way of pumping and flow. We have some motor efficiency, and we call it as motor efficiency as we have some drop down in the level of the efficiency of the engine. As there is some drop down and losses in the pump, as there are hydraulical and mechanical losses, and we call it pump sufficiency. As the pump sufficiency is increased, the loss percentage is going to be decreased. And this is related to the best choice and choose of the model of the pump and to the quality of its manufacturer and specification. As we have said earlier, the pumps are used to transfer the water from the low pressure area to the high pressure area, from tank A to tank B. And the pH equals rho, it is the mass. It is the mass, while J is the gravity, H is the flow, and H is the pressure, and Q is the flow. As for rho and J, it is constant, while H and Q are variable based on the studied cases. We are going to explain this equation and what is the best way of calculating the hydraulic power. The hydraulic power for the pump. It is going to be H total dynamic hub, multiplied by QS, which is the flow rate, multiplied by Q, the liquid density of water, multiplied by G, gravitational constant, and then we have the pH hydraulic power of pump by watt. Rho is 998 kilograms per square per metric square meter, not square, it is cubic meter. And G is 9.81 per meter per second. And we use it as Q. QS is Q on 3,600. So it is, the flow rate is cubical meter on per hour. So it's a Q divided over 3,600 to have the flow rate by cubical meter on hour, per hour. As for the power of the pump, we are going to talk about the power of pump. The efficiency of the pump is going to be represented, and it is going to talk about the loss we have. It is about the pH, which we had divided on the power of the pump. As a result, P2 is going to be pH divided on the efficiency of the pump. We are going to put that and replace it from the prior equation, and we are going to add this equation, this value. So P2 is going to be H total multiplied by QS multiplied by rho multiplied by G to be divided on the pump sufficiency or efficiency. Then from the second stage, we are going to find P2 H total multiplied by Q. We have replaced that by dividing Q on 3,600 multiplied on by 998. In addition to have to multiply it by the gravity, and then we divide on 1,000 to reach kilowatt. So we can reach the main equation and law of the bomb. We are going to implement that as example to reach out to, as a result, what we are going to use in real life. So we can see P2 is H total multiplied by Q flow rate divided on 100 O2 multiplied by 3.6 to multiply by the sufficiency of bomb to have kilowatt. We are going to use this equation only. This is the reference equation to have the power to reach, to know how much power is this this bomb giving. So Q is about cubic meter per hour. H total is by meter, 1 meter of water.
سوف ننتقل إلى حساب.
We are going to move to calculate how much motor power do we have. We have it as P2 divided on P1. So we are going to have it as mechanical power divided on the P1, which is electrical wiring. So we can have P1 as power, as electrical. P1 is the power in, which is the electricity power, electrical power, and we can see it through the current. He's using too many technical expressions. Sorry for not following up exactly with him.
إذا تحدثنا أن لدينا مردود المضخة ويساوي ناتج قسمة الاستطاعة الهيدروليكية مقسوما على الاستطاعة الميكانيكية المقدمة للمضخة.
So we are going to have it as these equations looking here, as you can see,
والذي هو ناتج قسمة الاستطاعة,
which is the result of dividing P2 on B1.
وبالتالي فإن
P1.
الإجمالي للمضخة يساوي حاصل جداء مردود المضخة.
So we can have it as a multiplication of the engine multiplied by the bomb sufficiency. Recently or currently, we are going to use Excel based on the equations we have used. This is going to be shared with you alongside with the presentation for this workshop. This is going to calculate the power of the bomb, so we don't need to use all these calculations again and again, and it is really put and easy implemented. So if we have 125 cubic meter per hour and the efficiency of bomb is 75% and the efficiency of bomb motor is 90%. We are having, as a result, power of bomb is 18.16 kilopounds. And the power of bomb as HB is 24.30p HB, 35 HB. While the power of motor as HB is 27.43 HB. While the power of motor as kilowatt is 20.17 kilowatts. Let's see if we increase the flow rate from 40 to 80 as double. The power is going to be increased for the bomb as double, and the power of the motor is going to be increased as double, as the relation between them is increasing. It's on the same line.
قبل الانتقال للقسم الثالث.
Before moving to the third part, we are going to give the floor to the questions and discussions as we are going to move to another part. If you have any questions, please come forward so we can make sure that all the information provided with loud and clear voice and you are getting the ideas.
Yes, I have a question, item. Between horizontal and vertical pump, what is the advantage or disadvantage to choose the horizontal or the vertical?
بالنسبة للمضخات تمام بالنسبة للمضخات العمودية
for the vertical and horizontal pump, there is no difference at all. The difference only is regarding the work settings and the place. The vertical pump doesn't require much space, while the horizontal one needs more space. The vertical one has its own power horse and watt, while the other one is not. They are similar, but it's based on the available space. While for the flow rate, for the bigger space flow rate, it is preferred to use horizontal. For the lower flow rate, we prefer to use the vertical one. And we are going to talk about the pros and cons. Do you have any other questions?
Thank you very much.
في أسئلة تانية؟ هل السؤال الشرح كان واضح؟ الصوت كان واضح؟ في تساؤل شيء حول شيء معين قبل ما
Is it clear? Is everything explained?
Yes,
clearly?
I have another
yes,
question, Haitham. You say efficiency of the pump 75%, but I would like to have 99%. Is that realistic, or how much can I expect maximal from a pump?
هلا بشكل أساسي كفاءة المحركات.
Basically, the efficiency of the pump motor usually used is between 88 to 94%. Those are for the normal pump motor. There are many very advanced motors. As for electrical motors, they have reached 97 or 98, but those in like almost zero conditions or special conditions. But it is costing a lot.
Okay, so the normal efficiency is 75 when you do the calculation.
بالنسبة للمضخات.
As for the bomb, it is between the perfect is 75 to 80 as for the bomb, while for the bomb motor is 88 to 94.
Thank you very much, Mr. Item.
بالنسبة للمحركات الممتاز.
While for the bomb motor, it is between 88 to 95 either.
Thank you.
طبعا بما أن هون صار في سؤال على المضخات، نحن راح نحكي كثير.
There is a question about the bomb. Many people through the contract usually they don't give an attention to the specification. One bomb is sufficiency is 80, one of them is 70. The price is not the price difference is not a lot, but we are choosing the cheaper, and then we are losing a lot. So the price of this pump would be really bad. As for example, I'm going to bring, if we have a pump where the efficiency of its electrical pump motor is about 100 kilowatts, so we have a loss about within the motor is 10% if the efficiency is 90%. And then we have some losses as 30%, 25% in the pump, so I have around 65% actual efficiency. So for every 100 kilowatts, I threw away 35 kilowatts. So when I use a motor, pump motor with less quality and less price, maybe I'm reaching higher loss, and this is not efficient at all. Exactly. We are going to move to the last part. It is about the pump performance curve, and it's very important. This curve is representing the special identity of each pump, and we can't use or deal with the pump without reading its curve. And the pump should be chosen based on its performance curve. And when we choose a pump without taking into consideration its curve, so we are going to run a pump maybe with no best condition, and it would work for a year and then it would break. So it is very important to look and consider that its chart. Maybe it is a malfunction in manufacturer and the selection. So the precise choose of the pump, maybe we can, with good choose, we can have the pump working for 30 years. But we need to choose it based on special specifications and the needs we are using it. We are going to talk in details about those specifications, which is representing the special identity of the pump, and no one can choose a pump without knowing what does it mean of its performance curve. We should have to conduct enough studies about those curves, and we are going to speak about them. The performance curve is providing each of pressure, consumption power, and the efficiency. And the ultimate pressure, it should be there as NPSHR based on the flow rate going into the pump. We are going to speak about it in detail. The first curve is the HQ curve. And this curve is very important. It is representing the relation between the flow rate and the compressor. So as the compressor value is vary, the flow rate is different. So if we have a pressure on that point, and when we apply this pressure on that curve, we can see how much flow rate we have, needed flow rate. And as it is vary, the flow rate is vary. And this is another chart of this curve. If we had this compressor, so we are applying this compressor on the flow rate, so we have 30 cubic meters per hour. While if we have so we have 50 flow rate square meters. So it is based on the compressor.
الخاصة بالموقع كيف يتم
It is based on the,
نقطة العمل المناسبة واختيار المضخة
so we are trying to choose the best bump suits our work and activities.
المنحنى الآخر
The other curve,
علاقة استطاعة المضخة مع التدفق
which is the
وهي
power Q curve,
تقريبا حيث أنه
and it is a linear relation.
تدفق المضخة كلما
It
زاد
as the increment in the power or the Q curve, we can have a different measurement of the power as KW.
وهنا نجد المنحنى الآخر B1 وهو منحنى
And we can see the other curve here as B1 in orange, which is the curve
المحرك
of the efficiency of the motor, while P2 is for the pump itself.
تحدثنا عن قوانينه سابقا.
And we talked about its equations earlier.
الآن إلى
Let's go to the
مهم جدا وهو منحنى
very important chart, which is the efficiency Q curve
والعلاقة
and the relation
خطوط المضخة والتدفق
between the efficiency and the flow rate.
يكون تدفق
So we can see when the flow rate is zero with a complete closure of the pump, we can see the efficiency is zero. And as the efficiency increases with the
وتسمى
Q,
نقطة الكفاءة
and we call the best efficiency point for the pump here as the peak of this curve. So it is very important to start this and make the pump work here, as it is very near the most sufficient point, so we can use it best. So if we can use this flow rate on 6 cubical meter per hour, so we can have efficiency as 77%, almost. But if we start this pump on 30 flow rate per hour, so the efficiency would be around 58%. So we would lose a lot of the efficiency as losses and harm to the pump body. The last curve from the performance curve is the NPSHR curve, which should be available at the entrance of the pump alongside the flow. It is very specific and it is complicated. For us, it is simple, but we are going to explain. It is among the performance curves. As the flow rate is increased, the NPSH would increase. It is the pressure required at the mouth or the entrance of the pump. So as it is increased, as the flow rate is increasing, so we need more pressure at the beginning or at the so at 70 cubical meter per hour, we need 3 meters of water pillar, or if not, we would have bad electricity at the pump, and maybe the impeller would be eating itself within a few months. We are going to explain that in details within the next workshop or next presentation. These are in general the performance curve for the pump. We can see the performance bumps for ground force company for one of the pumps they have. This is the QH curve, but those curves are, the first one is the efficiency of the pump, and here the efficiency, the total or the absolute efficiency. Here we can see B1, B2, and here we can see MPHF at the entrance of the bomb. Do you have any questions so far?
I think you can continue. If someone has question, it just has just to intervene or raise the hand.
Yes, yes. Thank you. سوف نشرح الآن ما هي طريقة
We are going to explain how the methods of testing bombs and drawing performance curves for bombs. We have talked earlier through the last sections about the performance of the bomb. But if I have been invited to test a bomb, or I have been asked to draw the performance curve for bombs, how can I do that? We are going to explain that in detail so we can understand exactly what are the performance bombs, the performance curve, sorry.
للقيام بعملية اختبار المضخة أو رسم منحنيات الأداء الخاصة بالمضخة لدينا المضخة بداية نقوم بتركيب
We have the bomb here
مقياس تدفق على مخرج المضخة ومقياس ضغط.
on the end at the exit of the bomb. It is meter per second and 1 meter of water. And we are installing a device here to examine how much water we have at the entrance of the bomb, and we have this valve at the exit of the bomb. At first, we close the valve so there is no flow rate and it is 0, and then we start the bomb. We can see that we have 6 kilowatts, while the compressor is 25 meters of water, while the flow is 0. Then we open the valve gradually. So we have different measurements. When it is 25 flow, we fix the valve and we read the parameters. So when it is 25 liters per second, we can see that the compressor is 19 meters of water, and we put it here, 19 columns of water, and it is 25 liters per second, and we have the efficiency increased to 8 kilowatts, and we add this to the curve, to the performance curve. Then we increase the valve opening, so we reach 50 liters per second, and we have 14 meters, and we have 10 kilowatts. Then we have the new points here, we draw them. It's 14, and the flow rate is 50 meters per second. And we add them to reach 10 kilowatts. And then we open the valve to have 75 liters per second, and we read the value of the compressor and how much electricity we are using, and we put drawing the point, the one before last, for the performance curve as 9 meters of columns of water, and it is about 75 liters per second, and we have 10.5 kilowatts. And to draw the last point, we open the valve until reaching its end and read the parameter. And we here can draw the power curve, and we have drawn that manually, and we have those curves through the calculation, and we replace the values here to see the efficiency of the motor and of the bomb. We have explained how we draw those curves, and to understand better how it is going to be affected through the power curve. So here everything is changing varying based on the flow rate. Now we are going to talk about connecting the pumps in series. Usually we have to connect the pumps in series, or in another way, let's talk about connecting them in series. Why are we connecting them on series? We use it to increase the value of the compressor. As we are doing it in series, the Q is equal to Q1 and Q2. While H total is B1 plus H1 plus H2. So it is cumulative for the both of the bombs. So we can reflect that on the power curve, and in black for each curve, for each pump. When we are doing that in series, so P1 plus B2, we can have a higher and double compressor flow rate. Maybe we need a higher pressure. So we connect those pumps on as in series. So we reach H total equals H1 plus H2, where the flow rate is stable for both of the pumps. We have spoken about how we use many stages, about impellers, and it is the same as connecting them in series. If we had 3 impellers in series, so we have the cumulative value of compressor equal to the compressor dedicated to each impeller as multiplied by 3, because impeller 1 plus 2 plus 3. In the submersible pump, we might reach 25 or 30 impellers. So we have this power curve and performance curve, and as we can see here. So the first one is the number of impellers, which is 1. So the pressure would be less as we increase 4 impellers, 6, 7, 8, 10 impellers. So we reach the pressure as it is how many impellers we have multiplied by the he's speaking quickly, technical language, sorry for this. So we have 10 impellers, so we can reach 100 columns of water. And this is going to increase gradually as we increase the number of the impellers and stages, and the compressor would increase. So each stage would receive the pressure from the previous one and increase it gradually until we reach the required pressure at the end of the exit of the pump. Now we are going to use about connecting the pumps on parallel.
يتم وصل المضخات على التوازي للحصول على قيمة تدفق أكبر.
We connect pumps on parallel to reach more flow rate, additional flow rate. So for example, if we have pump P1 with 50 cubic meter per hour and we need 100 cubic meter of flow, so we connect them on parallel. So we have the total flow rate is cumulative of Q1 plus Q2, while the pressure H is H1 equals to H2 equals to H total. So the pressure is the same.
إذا الهدف من وصل
So
المضخة على
the reason behind connecting them on parallel is to keep the pressure and increase the flow rate, as we can see here in the chart.
هو منحني علاقة
Here the curve is about the HQ relation,
منحني باللون الأحمر هو
while in red it is the curve about the pressure compressor P1 plus P2, how it is on parallel. So we can compare between the in parallel and in series two curves.
منحنيات الأداء للمضخات
Performance curves for pumps at different rotational speeds.
مقتضب عن
We are going to speak here in short about
حوالي 10 سنوات
using the pumps on different rotational speeds. And currently it is used on a very wide range in the advanced countries and
استخدام تقنية الانفرتر
developed countries. And it is used to measure and change the rotational speed of the pump.
أنه عند تشغيل المضخة
As we start the pump on the speed of 100%, we can have the flow rate at its maximum. While when we use it or start it at 80% of rotational speed, the flow rate would drop
على نحو كبير وتكون الاستطاعة قد نزلت بشكل
dramatically,
جيد أيضا
but in good performance. While we started on decrease it to 50% of rotational, so the flow rate would decrease less than 50%.
بالإضافة إلى ذلك تكون قيمة الاستطاعة قليلة جدا
So the efficiency would go low.
للتعامل مع اختلاف الاستهلاك على مدار الساعة حيث أنه
So we use it around the clock
التجمعات السكانية البسيطة على مستوى البلاد
for the simple population settlement.
وإذا أردنا أن
So it is because it should change from hour to hour. We need to achieve that by normal and traditional pumps. So we need bigger tanks. So we prevent
مرات الإقلاع
and decrease the number of ignition stopping times and frequency of the pump.
حيث عند ساعات الزر
So when at the 100% rotational, it is at the maximum flow rate, while it's drawing or dropping down, the rotational speed will drop down too. And then we can use a smaller tank rather than the traditional bigger tanks. And then the pump would work only when would be useful when there is smaller usage of the water.
نجد في هذا
We can see here in this picture the relation between N1 and N2, which is the speed we are changing,
كمية تدفق
and how much does it affect the pressure and the flow rate of water. So the speed would decrease and the value of the compressor. So when we use the inverter, we need to study the case precisely and based on timeline and based on the variety of the speed. So maybe if it is dropped below some values, so the pump would work without even sending any water, so it would result in increasing heat and malfunction later.
ومن الدراسة نجد أن مردود المضخة
From this study, we can see the efficiency of the pump would change based on the rotational speed. Many things at the end. I am going to give you the floor for any questions, comments, based on whatever you would like to discuss. I'm done. Thank you. Over to you.
Aitam, thank you very much for your clear presentation. From my side, just one question about a pump connected in parallel. In terms of efficiency, it makes sense to have two pumps on parallel, or it's better to have one big only for the same elevation?
دائما في الأنظمة الهندسية
Always on the engineering system, two pumps is better than using one pump, two pumps on parallel, and one as additional. So three pumps. If we have a load to reach 100 cubical meter of water per hour, so we put three pumps, each one producing 50 cubical meter per hour. So on parallel, so two of them would work and one of them would be as backup. So if we need to do any maintenance for one of them, so we stop that pump and we start the other two pumps. There is no way that in practical life and engineering life to use one bigger pump without using a backup pump for that. And the best system for that to be used is to have two pumps, each one of them would cover half of the usage, and the third one would be as a backup, so we can switch between those three to start two of them at the time and keep the third as backup all the time.
Thank you very much.
So,
So that's perfect. You were speaking exactly 1 hour was what we decided to. And please don't feel shy, ask question. That's the moment to take the opportunity to ask Haitam about technical question. And meanwhile, when you are thinking about a question, I just want to inform you that next week there will be the second part of this introduction to the pumps workshop. We will speak about the calculation of the total dynamic head. We will speak about drawing system curve for the pumps, finding the duty point for the pumps, and discussing about cavitation in pumps. Additionally, I would like to remember you that this webinar is going to be recorded, and it will be on YouTube by tomorrow. And now on the chat, I will just give you some information for those people who are not linked in my chat group. I just give you a link here. You can add it yourself on this group, on the link you will see. So you are going to be informed about the next workshop, not only about pumps, but we are going to touch other topics. Here in advance, in the same chat, I will give you the link for the YouTube channel where you are going to find the recording. And of course, if there is any question or any suggestion, you can contact me anytime. And here again in the chat, sorry, I will give you the contact of me. No, that's wrong, sorry. Is there any question to Haitam? If not, yes, there is a question. Haitam, that's a question for you. How to calculate the type of pipes, thickness, material, etc. we need to use in the motor of the pump parts of the equation?
تمام بس يعني نحن هذا السؤال نحن ما تطرقنا حاليا نعيد لنا
for this question, we haven't mentioned anything regarding the pipe. This topic needs a dedicated session. We are talking about the flow rate in zero conditions without mentioning anything about but regarding the thickness and the type of pipe, it needs dedicated sessions we can mention later on.
Okay, just to jump in for this matter, sorry. Thank you very much for the introduction, for the presentation, was very good. And my question is, if we have the pump with the X capacity, X strength, and we have it already, then to calculate the type of pipes, what does it go first? The piping or the pump? I don't know if it's clear. I know it's not a topic, but just a short answer, if possible.
ما فينا نحكي عن استطاعة المضخة.
We can't talk about the efficiency of the pump before the type of the pipe. The first thing to go is the pipe.
Okay, thank
We
you.
talk firstly about the pipe. We calculate exactly the next session is going to be about the pipe, type of materials. Is it old? Is it new? We can't speak about the pump until we finish speaking and studying the pipe.
Okay, that is very clear. Thank you very much. Thank you.
Thank you very much for
شكراً لك.
staying with us. And
البقاء
let's
معنا.
meet next week on the
وخلونا
15th
نجتمع
at the
الأسبوع
same
الجاي.
time.